Right then. So last time we had a look at perfect competition, and we laid out the assumptions, and we showed some how profit maximisation works, and so on and so forth. So we're going to look at this time is we're going to show how the model works in the short and long run, and also we're going to have a look at the idea of what do we understand by profits. So last time we've said that we said the profits are total revenue minus total cost. But what we said in the lesson is that economists define total cost in a particular way, which is different from the way in which an accountant would see it. And the example we use is we said, suppose Kelly was running her business, and she had total revenue of £100,000, and all of her costs, once she'd paid her staff and her rent and so on, were £95,000. Then her accountant would say, you've made a profit. You made a profit of £5,000. And we said, well, what does Kelly think about that? And what she said is, well, I'm not very happy. Because £5,000 isn't enough. And we said, well, why not? And she said, well, I could go and get a job. I could just go and work for somebody else, and I could earn £30,000 a year. So effectively, in this case, she's saying, well, I made £5,000 from running my business. I could have had £30,000 from just getting a job working for Microsoft or something, and therefore, I've lost that. That's an opportunity cost. I've lost that money. So effectively, the way she viewed it, is I've made a loss of £25,000, because although I've made 5,000, I could have made 30,000 more doing something else. So therefore, under these circumstances, you say, well, I'll close this, and instead, I'll go and work for Microsoft. So an economist says, well, that's quite interesting, isn't it? If effectively, therefore, Kelly is counting that £30,000 as part of her costs. So the way an economist treats costs is slightly different. The way we treat it is we come up with this idea of economic cost, and whenever we talk about costs, we're always talking about economic costs. And economic cost, from the point of view of an economist, is equal to all the paid costs that I sometimes call explicit costs, plus the opportunity cost of Kelly's time, which is sometimes called an implicit cost. And if we look at her numbers now, then we'd say her total revenue was 100,000. Her total paid costs were 95,000. We've then got to add in the opportunity cost, the fact that she could have gone and worked for Microsoft, for 30,000. We said, therefore, her economic costs are £125,000, which means that she's making an economic loss, of £25,000. So she's £25,000 worse off than she would have been had she gone and got a job working for somebody else. So an economist says, therefore, suppose total revenue equals total cost, the way we have now defined it, equals total economic cost, then that's kind of a pretty normal situation, so if total revenue equals total cost star, and you don't have to keep writing the star here because everybody knows. Everybody knows that. Sorry, everybody knows that when we say total cost, we mean total economic cost. Then at that point, it would be something like total revenue is 125,000, total cost is 125,000. But out of that includes the £30,000 that Kelly needs to pay herself. So when total revenue equals total cost, that's normal profit. And that will also mean that average revenue equals average total cost. Anything more than that, so we have anything above that, then we have abnormal profit. So, and if ever you're asked to explain abnormal profit, you can only ever do that via first explaining normal profit. Okay. So what we then said is we need to examine how the model works, given the assumptions that we had a look at last week, and that were in the last YouTube video. We said how does the model work? And what we said is, well, let's suppose that a firm is just making normal profit. So it's in long run equilibrium. So here's its industry, there's supply, there's demand, there's 1 trillion units or something. Yeah, this is some coffee grower in the Central African Republic that can sell large bags of coffee for £10 each. That links up. Yeah, that links up to there. So that's it can sell extra bags of coffee at £10. It can sell its average bag of coffee at £10, and we said that's also its demand line. There's money. We said if we're just making normal profits in the long run, suppose we know that average cost equals average revenue, but the key is the firm producing the profit maximising output where MC equals MR. And a lot of what we did last time is we just looked at different scenarios. We said, well, let's suppose something happens in the market, and let's suppose that there's some sort of shock. Let's suppose it's a positive shock, and let's suppose that demand rises to D1 like that. So everybody drinks more coffee, something along those lines. It's the opening of modern coffee shops and so on. So in the industry, what that means is the price is driven up to a higher level. The price is driven up to 15 quid. But of course that means that all the firms in the industry who are selling sort of 20 bags of coffee or something, all the firms in the industry, they now also have a higher price. So our little firm, that's not very straight. Our little firm, it has marginal revenue of 15 quid. It has average revenue of 15 quid. And its demand is horizontal at that level as well. So the next thing, the thing that people normally do wrong at this stage, is they forget that it's a two-step process. And when we're doing these diagrams, it's always a two-step process. Step one is we find the profit maximising output that we explained last time is where MC equals MR. So because price is now higher, units that previously weren't profitable, where marginal cost was greater than marginal revenue, now they are. The firm expands its output to 25 units. So the output at which MC equals MR now increases. Its revenue is now 25 times 15, which is some awkward number, like 375. So its revenue is then that large price times quantity area. But the key thing is, what are its costs? And to find its costs, and that's the second step of the two-step program, we look at Q star and we say what's total revenue and what's total cost. We've done total revenue. So what's its total cost? And to find its total cost, we find the output of 25 and we say what are the costs of making 25 units? And the answer is it's there on the average cost curve. It's not 10 quid. That's the cost of producing 20 units. We're producing 25 units, which is slightly above 10 quid. So what we've now got is we've got average cost of 11 quid. So that's 250, 275. Which is that area. We've got total revenue of 25 times 15. So the top area then is the abnormal profit. It's abnormal because we said that normal profit is just included inside the firm's costs. You can't see it on the diagram. So that is abnormal profit. In the short run, the firm can continue to earn those abnormal profits because no one can break in. And the reason they can't break in the short run is because of the definition of the short run. The short run is defined as the period of time in which there's at least one fixed factor of production. So if you haven't got that factor of production, you can't break into the market. In the long run, though, new firms can enter. And they'll want to do so because they want to take advantage of the abnormal profit. So what starts to happen is supply starts to rise. S1, S2. And it's going to continue to rise as long as there is abnormal profit. So as long as price is above 10 quid, which is the price at which normal profits could be earned, firms are going to keep on breaking into this market. And so they continue to do so until supply has risen to S3. So in the short run, we went from A to B, firms making abnormal profit. In the long run, new firms enter, and the market reaches equilibrium at C. For the firm, what's happened is that initially, output rose from 20 to 25, but now what's happening is that price is being steadily driven down, and its output is gradually falling. Because the price they're being offered is falling, the point at which profits are maximised, MC equals MR, is gradually being reduced. Fewer of these units are now worth making anymore, as you're offered a lower price, and therefore the firm cuts back. So the firm initially started there at A, expanded to B, and then ends back at C. So in the long run, again, so we were in equilibrium, long run equilibrium, then there was a shock which takes us into the short run, then firms either enter or leave, in this case they enter, which takes us back into long run equilibrium. Let's try the same thing. Let's try the same thing for a negative shock. So obviously it's going to be the same. It's going to be the same thing. But in reverse. What's going to happen this time? Is demand's going to fall. Firms are going to make a loss. As a result of which, in the short run, there's not much that can be done. But in the long run, some firms will leave the market. And eventually price will be driven back up to the equilibrium level. You might want to try doing this one first. You might want to put the video on pause, or you might want to wait at some stage. You might want to give it a go yourself, just on a piece of paper before we do this. So if you're going to do it, what you want to do is to show the firm again and industry in long run equilibrium. So that's the firm making 10 quid. In long run equilibrium, where MC equals MR, the firm's just making normal profit, which is there. And we call that, what was it, 20 units, and that's lots of units. And what we're now saying is, suppose there's some sort of negative shock. So what's happening is that demand shifts to D2. Coffee causes hyperactivity, or I don't know, whatever, bad things. So of course what happens is, because demand falls in the industry, growers are now only being paid £8 a bag. Now, that's not good news for them, because it means that parts of their production are no longer profitable. So because of diminishing returns, and we know we've got rising marginal cost, they no longer want to produce 20 kilos or 20 whatever it is. Because these units here are now unprofitable. Marginal cost is above marginal revenue. Therefore, the firm's going to cut its output to 15. And again, we don't do it, so that's step one. So step one, we find that MC equals MR at 15 units. And the question is, how much profit or loss is the firm making? Well, so that's step two. Always, is we find revenue. So that's so the firm's selling for 8 quid, so its revenue is now 8 times 15, which is that bottom area there. So we find average revenue times 15 units. And then to find cost, we now find average cost times 15 units. What's the cost of making those 15 units on average? And again, we're going to go, well, there's 15. We go up to the average cost curve there. We see that the firm's average cost is now 12 quid. So effectively, it's losing £4 units. Its costs are that large area. Its revenue is only the orange shaded area below. Therefore, it's making an economic loss of that area there, where costs are greater than revenue. So in the long run, in the short run, there's nothing that can be done because you're stuck in the industry. You've got a lease or something. In the long run, some firms are going to start going, well, this is a bit crap, and I don't want to be in this market anymore. And therefore, some of them will start to leave. At S1, price still hasn't recovered to allow normal profits to be made. At S2, price still hasn't recovered to allow normal profits to be made. So finally, at S3, price is back to 10 quid. The firm can now just cover its costs, including the opportunity cost of their time. At that stage, nobody wants to leave, nobody wants to enter, because we're only just making the same as if you went to work for Microsoft, and we're back in long run equilibrium. So in the industry, we started at A, B was the short run equilibrium, and we ended at C. For the firm, we started at A, where MC equals MR, we went to B, where MC equals MR, and then gradually MR was pushed back up, and we ended up back at point C. And that's perfect competition in short and long run equilibrium. That's the basic model. So all we're going to do this week coming up is we're going to look at shutdown and break-even decisions, or shutdown points particularly, which we touched on at the end of the last lesson, and we'll kick off with this time. And then we just got to really look at the extent to which we think perfect competition is an efficient or a desirable model, and that's what we're going to look at this week.